Hello guys, welcome you all for this end-to-end session of AIML, where you guys gonna learn everything that you guys need in order to become a successful data scientist. Hope you guys are enjoying. We are enjoying a lot, and we are learning a lot each and every day. So hope the same thing for you guys. So if you guys come to this server, please make sure that you guys all watch all the session videos, all the previous session videos, so that you can get a better understanding of what we are saying. Okay. So today it is a continuous session where we have started evaluation metrics for clustering as well as dimensionality reduction. Last session we have completed the evaluation metrics for clustering. Today we're gonna see dimensionality reduction evaluation metrics. So hope you guys gonna enjoy this session. And before that, if you guys have any doubts, please ping in the comment section. We will take up and we will solve your doubts. Okay. So this is what today we're gonna see this. So this is gonna be very simple session. So hope you guys gonna enjoy. And one more thing, guys, please subscribe to our channel, because every day we're gonna post a new video. Okay, so you will subscribe and then press the bell icon, so that you will get the notification whenever a new video is uploaded. Okay, let's start this session. It's gonna be very simple session. I will promise you guys. Okay, yeah. Dimensionality reduction evaluation metrics. Dimensionality reduction evaluation technique aims to reduce the number of features in a data set while preserving the most important feature. We already know, right? We have learned three different dimensionality reduction technique: PCA, LDA, and t-SNE. Don't worry about, guys, we have the sessions. Okay, please watch the session which we have done already, both the theory part, black box, as well as the coding part. If you guys doesn't watch, please make sure that you guys watch. Now we're gonna see the evaluation metrics. Okay, what is dimensional reduction? We're gonna convert the high dimensional data to low dimensional data such that we preserve the information. That's a major thing. Okay, not like you gonna convert a high dimensional data of nearly 1,000 features and only to 2 features, and gonna lose 80% of information. Then there is no point, right? You can take that original data and go for the analysis. Okay, you need to reduce the high dimensional data to the low dimensional data such that there is very less loss, or there should be no loss. Okay, so yeah, that is what dimensional reduction. Let's move on to its different kinds of metrics that we are having to play around this dimensional reduction. Yeah, explain variable ratio. I hope, like, if you guys watch our coding session or dimensional reduction, then it's going to be very easy, guys. Simple. Okay, explain variable variance ratio. This metrics measure the proportion of variance in the original data set that is captured by each principal component after applying PCA, that is principal component analysis. Simple. We are having 10 dimensional data, we're gonna reduce to 2 dimension. 10 dimensional data, we're gonna have 100% information. When you reduce to 2 dimension, the information become 19%. That is, the variance is 10%. That is what called as this explain variance ratio. Okay, you guys understand, right? Original data set, we are having 10 features. That is 100% information data. I'm applying PCA, that is dimensional reduction technique. I'm reducing the 10 features to only 2 features. Now the information is only 90%. That is 10% of variance in the information. That is explained by this explain variance ratio. Okay, hope you guys have understand. Okay, let us move on to the next metrics that we are having. Okay, yeah, reconstruction error. Okay, let's see what it is. Okay, original data. The original data point is in higher dimension, high dimension space. Dimensional reduction, the data is projected to a lower dimension. Reconstruction, the data is reconstructed back to the original space. Okay, this is called a reconstruction error. Okay, consider you are having a data of 10 dimension, you convert it to 2 dimension. After 2 dimension to 10 dimension scaling, you are reconstructing the data. There are going to be some error, right? That is called as reconstruction error. Okay, simple. Okay, so these are the two things. Okay, that is gonna evaluate this dimensional reduction technique. Okay, I hope, like, it's a simple thing, right? We are having a original data which is of high dimension. We are applying a dimensional reduction technique to move on to the low dimension. Again, we need to move for the low dimension to high dimension by applying some methods that is called as reconstruction, where there are going to be some error, some sort of error. While you are just converting from a low dimension to high dimension, that error is called as reconstruction error. Okay, that is one of the metrics for calculating the dimensional reduction evaluation. Okay, next. Yeah, let's end up. That's it. Okay, so what is the conclusion and key takeaway? We are having evaluation metrics. So evaluating machine learning models is crucial for ensuring their efficiency. By understanding the various evaluation metrics and their interpretations, data scientists can effectively data scientists can effectively access model performance to take informed decision. Yeah, that's true, right? So based on this decision, we can evaluate, okay, this model works for this data set or not, so that we can move on to the model, or we can fine tune this model. Yeah. So this is all about the metrics that we are having for dimensional reduction, guys. Hope you guys have enjoyed. Okay. So I will take some time to explain some more concepts. Okay. One thing, guys. So because like it's very less some session, let us discuss one more thing. Whenever you build a model, okay, whenever a data set is thrown onto you, first of all, we have discussed nearly like 4 different techniques, right? Classification, regression, uh, clustering, and dimensional reduction. Okay, today till now we have done with 4 different things together with its evaluation, coding, everything. Okay, let's see how many of you can able to understand these 4 things in a better manner. Okay, I'm gonna throw you some kind of problem statement, and you guys gonna say what kind of algorithm we need to use. Okay, first thing first, I need to find whether a mail is spam or not, whether an email that I'm getting is spam or not. What kind of algorithm I need to use? Okay, I will repeat my problem statement. When I'm gonna have a mail, whether it is a spam or not, what kind of algorithm I need to use? Okay, please put it in the comment section if you guys know the answer. Okay, yeah, the answer is classification. Okay, because there is only 2 things, and you're gonna have a labeled feature also. It comes under supervised learning, and it is gonna be classification feature. You're gonna classify the mail whether it is spam or not. Okay, let's move on to the next thing. I'm gonna predict the price of the house based on its number of bedrooms and square feet. What kind of algorithm I need to use? I will repeat my problem statement again. I'm gonna predict the price of the house based on the features like number of bedrooms and square feet. What kind of algorithm I need to use? Yeah, if you guys don't, just ping in the comment section. Okay, if you get right, if you guys have mentioned it is regression, it is right. Okay, because we're gonna predict a continuous value based on the labeled data, that is square feet, and then number of bedrooms. We are just finding the house price, right? House price is a continuous value based on the labeled features. We are just finding the value, so that is called as regression. Okay, let's move on to the next thing. Okay, now the next thing is, I am having a data of 1 lakh dimension. I'm gonna reduce it to only 10 dimension. What kind of algorithm I need to use? Guys, just ping in the comment section. I hope like you get all guys know what is the answer. Okay, so I will repeat my problem statement. I'm having a data of nearly 1 lakh features. I need to reduce it to only 1,000 features. What kind of algorithm I need to use? 1,000 or 100 features? What kind of algorithm I need to use? Okay. If you guys mentioned dimensional reduction, yeah, that is right. We're gonna convert the high dimensional of 1 lakh features to only to low dimension of 100 to 1,000 features. That's it. Okay. Final thing. Let's see how many of you gonna understand this. Okay. Okay. I'm having a problem of customer segmentation where I need to segment the customers based on their purchasing behavior. What kind of algorithm I need to use? I will just repeat my problem statement. I need to find customer segmentation where I'm gonna find what is the spend, that is how they are spending their money. Okay, that is customer segmentation. I'm just repeating my problem statement again clearly. Just look at it, you guys. Just hear it. I need to find customer segmentation. I need to find how the customer is spending their money. Okay, what kind of algorithm I need to use? Just mention in the comment section. Okay. Okay, if you guys mentioned it is clustering, that is right. Okay, so hope you guys have understand. So I will just give the gist of it. Classification algorithm, when it is supervised kind of thing, and you need to classify something, you need to go for classification algorithm. When you need to find some continuous value and it has a labeled data, then you need to go for a regression algorithm. So when you need to reduce the dimension of the data set from a higher dimension to lower dimension, then you need to go for a dimensional reduction technique. When and also the label there is no labeled data, and you don't have any labeled data, and you need to go for some kind of grouping, then you need to go for a clustering technique. Okay, so yeah guys, so that's it. So hope you guys have understand everything. Okay, till this point we have learned 4 different kind of classification that we are having in machine learning. Okay, hope that is a perfect clarity for you guys. So if you guys have any doubt, just ping in the comment section. We will take up and we will solve your doubts. So yeah guys, that's it of today's session. So we will all meet in the next session. Just practice guys, so because practice can make you well versed in these concepts. Okay, Okay, so if you guys have any doubt, just ping in the comment section. We will take up and we'll solve your doubts. Okay, until next session, bye guys, take care. We will all meet in the next session. Bye guys.